Okay, so here are our notes on finding area between curves. I'm just going to do one example, and then on Monday we're going to work with more problems that are going to have a higher degree of difficulty. But for right now, we're going to start with a fairly simple one. So I have two equations, and I want to find the area enclosed between these two equations. So we're going to do it two ways. We're going to do it with a calculator, and then we're going to do it without the calculator. So with the calculator, just like we did before when we were finding area under a curve, I want to know what does this curve look like. So the first thing we're going to do is we're going to sketch the graphs. Sketch the graphs. And forgive me if I misspell everything because I'm very tired and I'm really bad at spelling. So what happened to my straight edge? There it is. All right, so I'm going to sketch the graphs. So I'm going to do this with the help of my graphing calculator, although I picked two equations here that are actually pretty easy to graph. But for right now, we're just going to use our graphing calculator, and then we'll do it again, graphing them by hand. So on my graphing calculator, oops, got some old stuff in there. Let me take that out. Okay, so on my graphing calculator, I'm going to put in y equals x squared minus 4x plus 6. I'm going to graph that, see what that looks like. Okay, so it looks like I have my vertex is at 2 and 2, and my y-intercept is at 6. Okay, so I could actually use some of my functions to figure out the minimum. So if I want to know where is the vertex exactly, I can use my functions. Yep, it's at 2 and 2. Okay, so using my graphing calculator, there's my vertex, and I already noticed that it looks like the y-intercept is at 6, and I can tell that also by just plugging in 0 into my equation, and I'd be left with 6. So 1, 2, 3, 4, 5, 6. Also, because it's just a plain old x squared, just a coefficient of 1 on the x squared, I can go over 1 up 1, over 1 up 1, over 1 up 3. Okay, I can use that nice little rule to graph it. So there is my first function. And then my second function, negative x squared plus 4x. So I'm going to go ahead and graph that. Negative x squared plus 4x. Get that right? Yep. And graph that. There it is. So if I put that on here, it looks like it's crossing at 0, 0. I'm not sure where my vertex is, but it's a maximum, so I'm going to go ahead and use my graphing calculator to figure out what the maximum is. And it's at 4, so 2, 4, 2, 1, 2, 3, 4. There's my maximum. And I can graph that. So the area that is enclosed between them is right here. So let me get another color so you can see that clearly. This is the area that I am referring to. So in between. So that's the area I need to find. Okay, so what we were doing in class today is we were looking at other examples to help us figure out how to do this. And the idea that I was hoping you would come away with is that you can take the area of one and subtract the area of the other. Because if we were to use our graphing calculator to find the area under each curve, this first curve, if I go underneath it, I would be going, well, first of all, I'm going from this point to this point because that's where I'm enclosing my area. But I'd be going from here over to here. And if I were to find the integral of this curve from, this is 1, and this is, it looks like it's 3, I would get this entire area under here. I would get all of this, okay? And then if I were to take the other curve and I was to integrate that and also evaluate it from 1 to 3, I would get just the area under here, underneath that curve. And then I could subtract them, and I would be left with the area in between the two curves. Okay, so if we sketch that separately, what would happen if I was to integrate the first curve, so I'll just make a little sketch. So if I were to integrate the first curve, I would get all of this area. And that's too much. That's too much area. And then the other curve, sorry, that's, yeah. And the other curve, if I were to integrate it, and I was to do again between those two intersections, I would get all of this. Again, that's too much. So if I take this area and I subtract that area, I'm going to be left with this little part here. So that's what we should have figured out from our worksheet in class today, that you find the two different areas and then figure out who do you need to subtract from who. So the one that has the bigger area overall is the one that's higher up. So what we're going to be doing is we're going to find the integral. We're going to integrate the one that's higher up, so that would be this one, which is y equals negative x squared plus 4x. We're going to integrate that, so negative x squared plus 4x dx, and we're going to subtract from that the other area, this part down here. We're going to subtract that off so that we're only left with that little part. So that would be the other equation, which is x squared minus 4x plus 6 dx. Okay, so now though we do need to find precisely where are these intersections, so we can do that again on our graphing calculator. So I want to know where these intersect, so I can go back to my calculate menu and use option 5 for the intersection. And it asks me curve 1, curve 2, and guess where are they meeting? Bam, at 1 and 3. So I was correct. It looked like they were meeting at 1 and 3, and they are. And then I can do it for the other side. So again, the intersection. And I want to go closer to the other intersection, so I capture that one. So curve 1, curve 2, and yes, they are meeting at 3. X is 3. So I guessed those correctly. So I want to integrate each of these curves from 1 to 3. From 1 to 3. So now I can find the area of the upper curve minus the area of the lower curve. Okay, and it's at, I'm talking about upper and lower at the point where the area is. Okay, so this is the upper curve, the curve that's on top, farther away from the x-axis, and this is the lower curve, the one that's closer to the x-axis. Okay, so I'm going to subtract the lower one from the upper one. Okay, so then I can go ahead and I can just do this in my calculator, super easy. So I already have them in there, so I'm going to go second calculate, and I want the integral, and let's see, which curve am I on? I'm on the red one right now. That's the upper one, that's this one. So it says lower limit, that's 1. Upper limit, that would be 3. Hit enter. And I get 7.3 repeating, so that would be 7 1/3. So this area is 7 1/3. And then I can do this one as well. So back to 7 again. This time I want to make sure I'm on the other curve. There I am. So I use my arrows to make sure that I'm on the correct curve. It says lower limit. Again, that's 1. Upper limit is 3. And that's 4.6 repeating. So this would be 4 2/3. And then I'm going to subtract. So I have my area of the first one and the area of the second one. So again, I'm using my calculator. And so I'm going to do 7 1/3 minus 4 2/3. In order to put that into my calculator, it's helpful to write those as improper fractions. So 22, so that would be 22 over 3 minus, that's 12, 13, 14 over 3. Actually, I could just do this by hand, can't I? So 22 minus 14 is 8 over 3. And then I can change that back to a mixed number. So that would be 2 2/3. And then it's an area, so it would be units squared. Okay, so that's one way of doing it with the graphing calculator, but there's actually another way I could do it. I could actually do the subtraction of the integrals before I take their area. And this is going to be helpful when I do it by hand. Okay, so I'm going to actually show that when I do it when I do it by hand, because that way it saves a lot of work. But actually, you know what, let's just do it here with the calculator first. So instead of integrating these separately, I can actually subtract them first and then integrate them. Okay, so I'm going to give that a try. So, or subtract first. Subtract them first. So I'm going to take my the upper curve, and I'm going to subtract the lower curve. So if I subtract those, I have negative x, well, let's go ahead and distribute the negative. I better do all the steps because I know I have quite a few students who tend to lose their negatives. So let's not lose our negative. So I'm going to distribute this negative. Negative times x squared is negative x squared. Negative times negative gives me plus 4x. Negative times 6 gives me negative 6. Now I can combine my like terms. Negative x squared plus negative x squared is negative 2x squared. 4x plus 4x is 8x, and then the minus 6. So now I'm going to integrate that. So I am now going to integrate negative 2x squared plus 8x minus 6, and I'm going to do it from 1 to 3. Okay, still those same intersections. And I'm going to put that into my calculator. So clear out the ones that are in there. And I'm going to put in negative 2x squared plus 8x minus 6, and graph it. There it is. Okay, and I'm looking for the area between 1 and 3. So second, calculate. Option 7. My lower limit is 1. My upper limit is 3. And I get 2 2/3. Is that what I got before? Phew! Yes, it is. So that equals 2 2/3. Okay, so I hope you can see that if we were to do this by hand, doing the subtraction first and then integrating the result is going to be much easier than taking both of the integrals and then subtracting them. Okay, notice you get the same answer. So when we do this by hand, it's really to your advantage to go ahead and subtract the functions first. And I know that seems really weird because when you look at the picture, you're like, well, that picture doesn't look anything like that picture. But it is an equivalent equation. So these two being subtracted from each other gives you a new equation that will have an equivalent area between the curve and the x-axis. Kind of crazy, but it works. All right, so let's go ahead and do it by hand. So we're going to do the same problem by hand. So when we do it by hand, so without a calculator, you want to subtract the functions first. So my functions again, let's write these down, were x squared minus 4x plus 6, and y equals negative x squared plus 4x. So subtract before integrating. To save work. Okay, but math is about being efficient. We want to do things efficiently. Okay, so we're going to take the upper curve. Okay, it's important to recognize which one's the upper curve. The upper curve was the negative x squared plus 4x. So I'm going to take my upper curve. So you're going to do upper curve minus the lower curve. And then we're going to integrate that on the boundaries, dx, right? Okay, so I'm going to integrate so I don't have to keep writing this integration symbol right now, but what the heck, let's just do it. So the upper curve is the negative x squared plus 4x. The lower curve is the x squared minus 4x plus 6. We're going to subtract those. We already did this on the other page, okay? So if I can just copy that over from the other page, I know that leaves me with negative 2x squared plus 8x minus 6. And I'm going to integrate that from 1 to 3 because we would have found their intersections. Oh, I forgot. How do we find their intersections if we don't have our graphing calculator? Okay, so you know what? Let's go backwards. Okay, so that's what we're going to integrate. Now we need to find the boundaries. So to find boundaries, set equations equal to each other to find their intersections. Okay, set them equal to each other and solve. So I'm going to have x squared minus 4x plus 6 is equal to negative x squared plus 4x. So to solve a quadratic, I need it to be equal to 0. So I'm going to move my x squared over here. So I'm going to add x squared. Notice I'm doing a lot of steps. I know a lot of you don't need this, but I'm doing it for those who do like to see every single step. Still want it to be equal to 0, so I'm going to minus this 4x. Okay, now I need to factorize this. I notice they all have a 2 in common, so I'm going to divide both sides by 2. So if I divide, let's see, am I going overboard showing too many steps? I'm going to divide both sides by 2. So I'm going to divide by 2. I'm going to divide both sides by 2, okay, and I'm going to be left with x squared minus 4x plus 3. I know that's not like great notation, but I don't really want to write it again because I'm running out of room. Now I can factorize that. X times x is x squared. 3 times 1 is 3. To get a positive here and a negative here, these both need to be negative. And now I can solve these. X minus 1 equals 0, and x minus 3 equals 0. So x is equal to 1, x is equal to 3. So that's how I get my boundaries. Okay, so now I'm going to put those back onto my integral. So continuing here, I'm going to write my integral from 1 to 3. So I've just demonstrated how do we find the intersections without a graphing calculator. We set the equations equal to each other and solved. So now I'm going to copy this over. Negative 2x squared plus 8x minus 6 dx. Did I copy it over correctly? Yep. All right, now I'm going to take the antiderivative. Okay, so then and solve it. All right, so nicely, I can do each one of these separately. So I'm going to add 1 to my exponent. I get x to the third times 1/3, and then times by that negative 2. The next one, add 1 to my exponent. I get x squared times 1/2, and then keep my 8. Minus, it's a constant, so I just put an x next to it. Okay, and that is now going to be evaluated from 1 up to 3. So when I do my evaluation, I'll go ahead and simplify this. So I'm going to have negative 2/3. Negative 2 times 1/3 is negative 2/3. My x is 3, so 3 cubed. Plus 8 times 1/2 is 4 times 3 squared. Minus 6 times 3. And I always write too big. Now I don't leave enough room over here. Sorry about that. So negative 2/3 times 1 cubed plus 4 times 1 squared, because 8 times 1/2 is 4, minus 6 times 1. Okay, simplify that. 3 cubed is 27. 27 divided by 3 is 9. 9 times negative 2 is negative 18. 3 squared is 9. 9 times 4 is 36. Minus 18. And let's see, negative 18 plus negative 18 is negative 36. Negative 36 plus 36 is 0. Holy cow, that one just equals 0. Right, what's going on over here? 1 cubed is 1 times negative 2/3 is negative 2/3. 1 squared is 1 times 4 is 4. And negative 6 times 1 is negative 6. Let's add my integers first. 4 times negative 6, 4 minus 6 is negative 2. Negative 2 plus negative 2/3 is negative 2 2/3. Okay, these two together are negative 2, and then another negative 2/3 gives me negative 2 2/3, and then minus a negative gives me my final answer of 2 2/3. Is that what I got when I did it with the calculator? I don't even remember. Oh, please say yes. Please say yes. 2 2/3. There it is. Okay? So obviously with a calculator it's a lot easier. You just need to figure out what are your boundaries, and then you can find the areas separately and subtract them, or you can subtract the two equations and then take the integral. Doing it by hand obviously is a lot more work. You need to, you also need to graph these because you don't know which one is the upper one. Okay, so you need to sketch these graphs. So I sort of neglected to sketch those graphs because we had done it before. But we could certainly sketch these graphs. They are, you know, we could find the vertex and the y-intercept, and we know it's an x squared. Okay, so we could have graphed these by hand to figure out which one's the upper one and what's the lower one. Something interesting though, what if we did it backwards? What if we said this one was the upper one and this one was the lower one? What would happen if it basically would just be these would be switched? If I thought this was the upper one and this was the lower one. So if I were to just switch these, what would happen to my area if I were to just switch these? I would get a negative. Okay, so if you ended up swapping these and having the wrong one on top, no big deal. You would end up just with a negative area. You would end up with negative 2 2/3. And so that would be a little hint to just, oh, I had the wrong one on top. Let's take the absolute value. Okay, so it's not that big a deal if you actually get them in the wrong order. Okay, but it is kind of nice to have an idea of what you're doing by graphing, by sketching the graph before you start doing the integration. All right, that's it. Have a great weekend.